In this video, we're going to be simplifying radicals. In order to simplify radicals, we take advantage of the rule that says the square root of a times b is equal to radical a times radical b. The goal that we have for simplifying radicals is to have a equal a perfect square. So we're trying to divide out 2 squared, which is 4, 3 squared is 9, or 4 squared, which is 16, 5 squared is 25, 6 squared is 36, and so on. So there's your long list of some of our first perfect squares. Notice we don't care about 1 squared, because when you divide by 1, you don't change anything. So let's jump in and take a look at an example of how this works. We want to simplify radical 18. So we're looking for the first perfect square that divides out of 18. So I know you can divide 18 by 2, you can divide it by 3, but those numbers are not in our list of perfect squares. The first number in our list is 9. And so we end up with radical 9 times radical 2. And then our last step is to just simplify radical 9 into 3, and then we end up with a simplified radical of 3 radical 2. Let's try it on another one. Square root of 150. So again, the best strategy is to try to find the largest perfect square that can be divided out of 150. We can't divide 150 by 4, can't divide by 9, can't divide by 16, but we can divide by 25. You might think of that as 6 quarters would be $1.50. So let's rewrite this as radical 25 times radical 6. And then we just simplify our square root of 25 into 5, and we get a final answer of 5 radical 6. Now there is another strategy you can use if you're having trouble coming up with what perfect square can be divided out of your number. This strategy works good when you have a larger number. So let's take a look at radical 150 again. If we break this down into its prime factors, we can then simplify. So if we start with 150, can you divide 150 by 2? And the answer is yes. That would be 2 times 75. Can you divide 75 by 2? No, you can't. So go to your next prime factor, which is 3. Can we go 75 divided by 3? Yeah. So 75 divided by 3 would give us 25. Can we divide 25 by 3? No, we can't. So we go to our next prime factor of 5. Can we divide 25 by 5? Yeah. 25 divided by 5 leaves us with 5, which can be divided by 5. Once you have the same number on the outside as you do on the inside, you know that you have all your prime factors. So now we can rewrite the square root of 150 as the square root of all these prime factors. Now, since we're doing square root, we are looking for a pair of factors. Each pair can come to the outside. In this case, we have a pair of 5s. So that means our 5 can go to the outside of the square root, and we still have 2 times 3 on the inside. Our last step would be to simplify 2 times 3 and come up with 5 radical 6. Same answer as before, just a different method that you can use to find it. This method works best when the number's big and you can't figure out what perfect squares you can divide out. If you're feeling confident, go ahead and pause the video and try these 4 problems out. If not, you can just do them with me. Alright, let's take a look. Radical 90. Is there a perfect square that we can divide out of 90? Yes, we can divide 90 by 9, and that would be radical 9 times radical 10. And then you just need to simplify your radical 9 into a 3 radical 10. Alright, next up, radical 48. The biggest perfect square that you can divide out of 48 is 16, and that would leave you with 16 times 3. Now we just simplify the radical 16 and get a final answer of 4 radical 3. Now it's also possible that you looked at radical 48 and you decided to take out radical 4. Then you would have radical 4 times radical 12. But you're not done simplifying. You would have to recognize that radical 12 has another perfect square in it, a 4. So the radical 12 would have to be simplified to radical 4 times radical 3. Then your radical 4s become 2's, and then you simplify to 4 radical 3. So if there's more than one perfect square that can be divided out, if you can identify the biggest one, you'll solve your answer much quicker. On 252, I was unsure of what perfect square comes out, so I decided to just break that one down. So 252, can I divide it by 2? Yeah, it's an even number, and I'm left with 126. I can divide by 2 again, and I'm left with 63. 63 can be divided not by 2, but by 3. And I would be left with 21. 21 can be divided by 3. And I'm left with 7, which can only be divided by 7. So those are all my prime factors, and I can rewrite radical 252 as radical 2 times 2 times 3 times 3 times 7. Notice that I have a pair of 2's and a pair of 3's. So that means I can take a 2 and a 3 and move it to the outside, and I'm left with a 7 on the inside. Then I just simplify my 2 times 3 and get a final answer of 6 radical 7. All right, last one, radical 98. If you recognize that 98 can be divided by 49, you just go radical 49 times radical 2, and then simplify to 7 radical 2. If you didn't identify the 49 right away, if you tried to take out a 2 from 98, you'd have 49 left, and then you'd recognize your perfect square. Another part of simplifying radicals is what do we do with fractions? So there's a simple rule for this. The square root of a divided by b can be rewritten as radical a divided by radical b. Let's take a look at an example problem. So we have the square root of 25/16. So our first step is just to rewrite this as radical 25 over radical 16. And now these are perfect squares, so we can go ahead and simplify. The square root of 25 gives us 5, and the square root of 16 is 4, and there's your answer. Let's try another one. Square root of 150 over 18. So our first step is to go ahead and separate them into two separate radicals, radical 150 over radical 18. Now we just have to simplify these radicals. So radical 150 can be radical 25 times radical 6, and 18 becomes radical 9 times radical 2. We can simplify the perfect squares, and we're left with 5 radical 6 over 3 radical 2. However, we don't like to have radicals in the denominator. So we can further simplify by turning radical 6 into radical 3 times radical 2. Now we can cancel out the radical 2 on the top and the bottom. So we're left with 5 radical 3 over 3. Now it turns out there's a much quicker way to solve this same exact problem. And that is, what if we reduce the fraction as our first step? So 150 and 18 can both be divided by 2, which would give us radical 75/9. Now we go ahead and separate this, radical 75 over radical 9. On the bottom, we have a perfect square. On the top, radical 75 can be simplified as radical 25 times radical 3. Now we just simplify our perfect squares, and we go right to our answer, 5 radical 3 over 3. So, just like when you're factoring quadratics, if there's a way to reduce and simplify your problem at the start, that usually makes it a much easier problem to deal with. One of the most common uses for simplifying radicals is when you're using quadratic formula to solve an equation. So here we have an answer that looks like it came from quadratic formula. And we can go ahead and continue to simplify it because the radical 20 can be simplified. So our first step would be to simplify the radical 20 into radical 4 times radical 5. Now we can go ahead and turn that square root of 4 into a 2. So we simplified the radical, and now we got negative 6 plus or minus 2 radical 5 over 2. It turns out we can continue to simplify this one, and the reason is we could actually rewrite this and split it into two fractions. Negative 6 over 2 plus or minus 2 radical 5 over 2. And then we can simplify these further, and negative 6 over 2 simply becomes negative 3, and we get plus or minus radical 5 because the 2 over 2 cancels out. In fact, if you recognize that the bottom factor can be simplified out of both this number and this number, you can probably go directly to your answer without splitting it into two separate fractions. And that'll conclude our video on some ways that we can simplify radicals.